Hi there, this is Dr. Snyder again. Thanks for stopping by. This is COP 1000 and we're going to continue looking at lesson 2. The main topic today is going to be going over algorithms, flowcharts, and pseudocode. We'll get into some examples, the tools that we might use to create these things and get them turned in, and it should be fun. So let's jump right in. So what is an algorithm? Well, in general, it's a sequence of steps used to solve a problem. You could think of a recipe for baking a cake or a map that tells you how to drive from point A to B. Those are both algorithms. If you like Swedish furniture, looking at the instructions on how to assemble a bookcase falls into this category. There's lots of examples I could use. In general, it's simply what steps you use to solve the problem. Now, we specifically think of it in terms of when we're trying to solve a problem using a computer. That's the typical context for the word algorithm. When you are at the grocery store and you're talking to your significant other about which line should we get in so that we get our groceries paid for and get to the car quicker, you typically use the word algorithm to describe, hey, let's come up with an algorithm. It is an algorithm, but we just usually use the word in the context of solving a problem with a computer, and here's the sequence of steps used to solve that problem. The point of this slide is to simply describe the levels of detail from very, very specific to very general and vague in which to convey the design of an algorithm. When you look at the extremes, let's say we're trying to find who committed a crime. Perhaps we've got a napkin that has the DNA of the crime suspect on it. Well, we could send it to the lab, we could analyze the DNA, we could compare it to known suspects that we have in custody, and the whole works, but that's going to take a lot of people, a lot of time, and it may be several weeks before we come back with an identification for who we're looking for, as opposed to a very rough sketch of the person on a napkin that we make copies of when we pass out, get them out there on the street, and it's not going to be as precise. Maybe many people match that description, but we can get it out there very quickly. So each one has its purpose and each one has pros and cons, I guess I would say. Similar to if you're trying to describe the instructions for how somebody should get to a destination, you might just hastily sketch them out a map on a piece of paper, and that might do the job. That might get them to the destination, as opposed to going to something like map software like Google Maps. Then you could get a very precise set of steps on how to get from A to B that would be very unlikely for them to make a mistake. And that's the way it is with flowchart and pseudocode, which are the two main ways that we're going to discuss in this class on how to express our algorithms to one another. And the biggest thing I guess I want to say is when we talk about flowchart and pseudocode, this is meant to convey our design to other humans. It's not meant to produce something so detailed that we can stick it into the computer and run it and get the results that we were looking for. So I guess many times I'll see students that they jump right into the code, they write their code, and then they'll think, well, I'll just copy and paste the code to turn that in as my pseudocode. Or when they sit down to write their pseudocode, they start out by writing programming code. That's much like the DNA versus the hastily composed crime sketch. We don't need that level of detail. If you are down to the point where you're putting semicolons and curly braces and actual programming code on the design, you're spending way too much time thinking about it in too much detail, and that's not what we're going for. We're going for something quick that organizes our thoughts, get it communicated quickly, and move on to the next step of our as we're calling it, our homework life cycle. So don't spend a whole lot of time on a pseudocode. Just get organized, move on to the flowchart. Don't spend a lot of time on the flowchart. just get your logic correct and move on then to the code. When we get to the coding part of it, that's when we're going to want all of the detail. That's when we're going to have to follow all the rules of the programming language. So that'll come in time. Just when we're practicing doing pseudocode and flowcharts, we are practicing taking a moment, taking a breath, and organizing our thoughts before we move into too much detail. So when I am given an assignment, I'll be asked, look in the assignments, and it will specify, I'll say, here's what you're supposed to turn in. Sometimes I may not ask for flowchart and pseudocode. If we already reinforced that and I just want to give you a little variation and I just want the Python code, maybe I'll ask for that. But I'll be specific on the assignments as to what to turn in. But if you're asked to produce a flowchart, make a flowchart. There's many different ways that we can make a flowchart. They can look very nice and polished and have little colors assigned to the boxes and things, or they could be very general. But what I'm going to say is the students that more often get full credit for their flowcharts do it the clean, precise way where it's not ugly, it doesn't have coffee stains on it. It's a professional looking attempt at the assignment. It's not sloppy, I guess I would say. So I'm going to expect some level of neatness in your flowcharts that you turn in because it's my job to grade them. But there's many different ways that you can create a flowchart. I get students asking me, do I have to use this tool to create my flowchart? No, you don't have to, but the tools that I'm recommending that you use allow students traditionally to get the closest to ensuring full credit on their assignment. And that's what I'm going for here. So one of the cool things about the tool that I recommend, there's two of them, Flowgorithm and Raptor. There may be others out there, but those are the two that I'm familiar with. Raptor's a little older tool, and if you use it, it looks a little bit more primitive. Flowgorithm is newer. It's a little prettier, but the bad thing is right now Flowgorithm doesn't run on a Mac. So if you have a PC, I would recommend you use Flowgorithm. If you are on a Mac, try to use Raptor, and if you can't get either one of those to work, you're not blocked. You can draw it on a piece of paper and take a picture of it with your phone and turn it in that way if you really had to. But just keep in mind it's going to be difficult for you to get full credit just because it's so easy to make little silly mistakes and not get it right when you don't use the tools. So pseudocode, similarly, we could just write our steps out that we're thinking, hey, I'm thinking this is what it's going to take to solve this problem. We can just write it out on a piece of paper, take a picture of it, and turn it in. You take the risk of me not being able to read your handwriting. Neatness counts. You have to convey your information. That's what we're testing here, is that your ability to convey your design to another human, being me, your teacher. And so neatness is going to count. You could open up a simple text editor like Notepad and type your steps in there, which is what I'm going to recommend you do. There's other ways to do it, but that's the way that's easiest for me to grade and is the simplest. We don't require lots of different features and things for creating our pseudocode, so I'll be recommending that you do it that way, just with a simple text editor. So another point that I want to make here is if you have issues with your flowchart and your pseudocode, try to detect those errors up front. But if you show an evolution of your design from your pseudocode to your flowchart to your code, that's pretty natural. I may still count off points if it's incorrect, so I would encourage you to correct it. Right now, we're not in a development team where you're given some very complex 6-month-long assignment where it's natural for you to evolve your design over time as more details are fleshed out and you get nearer to a professional solution that you're going to say is complete and tested and working properly. In here, we're practicing getting it right. So, but I want to make the point that in general, in practice, the the designs are initial, they're preliminary, and it would be natural for you to come up with an initial pseudocode of your design and then evolve it by the time you finish your code. That's okay, but in here I'm going to expect it to all be correct because you're doing it for a grade. As I said, look at the assignment to see what you're supposed to turn in. The files that you will turn in will be listed there, but also there are coding standards to follow that we'll discuss in class as we get further into it. I'll be expecting a certain level of detail in your comments. I'll expect you to have tested your program with certain, number of test cases and things like that, and that you've turned it in properly so that it makes it easy for me to grade it. The easy for me to grade isn't the main concern, but when I'm going through a list of 30 students' assignments, you don't want to stand out because yours was the hard one for me to grade. That's not something to be called out for in a positive way. So you want to try to make it, I've designed these so that the method of turning in the assignments is a streamlined process, so I'm not wasting a lot of my time on immaterial exercises. I can focus on giving you the feedback. I don't want to be off solving other problems than that. I want to focus on your code and giving you good quality feedback to help you get better. Oh, another thing that I wanted to point out before I move on here, that last bullet point there, always when you're in Canvas, always turn in all of the files that are requested. One of the idiosyncrasies of Canvas is that it doesn't keep all the files. So let's say you, on an assignment, you turn in your flowchart, your pseudocode, and your Python code, 3 files. Then you realize, I wanted to correct something, and so you go to, let's say, your Python code, and you fix a typo, you add some comments, you polish it, make it look a little bit better. Then you go back to Canvas and you only upload that Python code. Well, I'm going to then count you off because Canvas didn't keep your flowchart and your pseudocode from your previous attempt. So every single time you make an update, you need to turn in all the files for the assignment. So that's a little gotcha hopefully I can save you from. So here's one thing that I want to also point out that will hopefully save you some headaches. Windows is an operating system that's meant to be easy to use by regular users. When we start learning to program, you'll find that we're sort of leaving that class of computer users where we need the operating system to perform in different ways by default. And one of those is when you look at a folder that's full of files, if you notice in this screenshot, there's 3 files here that are called program. Well, which one of them is the one that has my Python code in it that I'm supposed to turn in? I can't tell from looking at the file types. And so one feature of File Explorer that's important for you to realize is that you can tell File Explorer, I want you to show me the extensions, the file extensions on these. So I think there's different ways of doing it depending on what version of Windows you're using. But in the Windows version that I'm using, or that I used to create this slide, you go to the View menu, click the Show, and then there's a file name extensions that you'll make sure that the little check mark is to the left of it. In newer versions of Windows, I believe you might just click the View button, and it's a checkbox there that says Show File Extensions. You want to make sure that that's checked. And once you do that, then the view changes so that now I can see those 3 files that are named program, and they have the file extension next to them. So I can see that the first one is a C# program, the second one is a Java program, and the third one is my Python program that I want to turn in. I see students sometimes they get frustrated by how this works, and they'll sit there and they'll try to rename their program, and I get people turning in files that are program.py.py.py because they're trying to do something to get Windows to show them the file extension when all you have to do is go to the View menu and turn it on so that it will show you. Hopefully that helps avoid a headache there. Yeah, so that looks much better as a programmer, as somebody that's more of a power user like we're becoming. It's just nice to see what those file types are. Sometimes the little icons on the side will indicate or give us extra information about what we want to know, but not always. And so the file extensions are the way to get that. Okay, so let's look at some examples of algorithms and talk about what makes a good algorithm and a bad algorithm. So if we're sitting around the house and I say, go to the store, we're out of eggs, go to the store. So I have given you a problem statement, but is it a good problem statement? And that begs the question, well, what makes a problem statement good or bad? And it centers around the amount of the level of assumptions that I'm requiring the person that solves this problem to make. We all know what the saying is about when you assume, but this particular problem statement assumes that the person knows where the store is. It assumes that they know what it is that is needed to be purchased at the store. What kind of store? The hardware store, the grocery store. There's a lot of things there that are omitted. And just like with the term algorithm is usually used in the context of a computer problem, in similar ways, when we talk about what makes a good and a bad problem statement, we're talking about in the context of writing a computer program. And so we're going to think about things like, what are the inputs to this problem? What are the outputs that it's supposed to produce? What are the processing steps that are required? Are there any dependencies on other things being done or being present or being completed, such as, is the store closed right now and I need to schedule a time in order to go to the store? Are there any assumptions that are being made? As we discussed with this, there's probably a lot of assumptions being made here. So here's a better problem statement. Get $20, get the car keys from mom, drive the car to the Piggly Wiggly on 3rd Street, and park the car. Go into the store and get a gallon of 2% milk. Purchase the milk and drive back home. Put the milk in the refrigerator. I could have probably been more explicit and added more steps. Now, we don't usually talk to other humans that way because we assume that humans are capable of making some assumptions and inferring what was intended in a lot of cases. So we don't go to that level of detail. But some of this is useful. Like, I don't expect for you to pay for the groceries yourself. Feel free to get $20, okay? Get the car keys. I don't expect you to use your own car. Which store that I would prefer you to go to. What we're supposed to get at the store, the 2% milk. I don't want you to grab the milk off the counter and run away with it. I want you to purchase it. That's probably something we could have inferred. And then put the milk in the refrigerator. Again, when you get home with the groceries, we typically include putting away the groceries as part of that task. So maybe we didn't need to go to that level of detail. The point being, this is a much higher quality problem statement than go to the store was, and for the reasons that we specified. So in the real world, when you're working, when you're getting paid to write computer programs, you don't always get all of the details. You may not always get all the details for an assignment. For me, it is okay for you to ask clarifying questions. Hey, when you said get a number from the user, were you expecting it to be an integer or a floating point? Things like that. You can ask qualifying questions if you're unsure. So the last statement there that I will make is, when you go to a job interview, many software companies, when they're interviewing candidates, they expect this and they test for it. They give you a problem statement to see whether you as a candidate will jump in and start writing code without knowing what was intended, or with a vague problem. They want to test you to see if you make assumptions, and it's expected that programming candidates will stop, think about the problem, state it back to the interviewer, and ask any clarifying questions that they might have before they jump in and start writing the code. So just keep that in mind for later. So here's another problem example. Let's talk about whether it's good or bad. Add two numbers together and print the result. So think about that, whether you think that that's a good problem statement or not. So we would qualify that with, are the inputs specified? Well, it says to add two numbers together, but it doesn't exactly say where those two numbers are supposed to be coming from. Am I supposed to read them from a file? Am I supposed to ask the user to enter them, etc.? Okay, the outputs. It says print the result. Okay, so it says add two numbers together. Is the sum of those two numbers the result? We can probably infer that from this problem statement, but boy, it would be nice if it was clarified. The processing steps required. Well, I did say add the two numbers together, so it looks like we did get that information. Are there any dependencies, other assumptions that we're making? Yeah, it's not bad. It's typical of the kind of problem that you will get as an assignment, and will be expected to infer all of the other pieces of information, but it sure could have been a lot more detailed, couldn't it? Here's another problem. Calculate the distance between 2 points. It sounds very similar to the first problem. The distance between 2 points. So let's talk about inputs. Where are the inputs coming from? Between 2 points. So the 2 points are inputs, it looks like. Well, in what form are those 2 points going to come is what I would ask. Are they Cartesian coordinates? Are they polar coordinates? Is it two-dimensional space on a plane, or is it in 3 dimensions? Am I calculating orbital trajectories? You know, give me some more detail about that. You know, if I have two destinations on a map, you know, the address of one place and the address of another place, then I can calculate the distance between those 2 points over a road, making turns and going up and down hills and valleys, etc. So I might need to include that in the distance versus if I'm walking someplace. Am I walking directly? Do I have obstacles, etc.? So that's the kind of stuff I would ask about those 2 points. Tell me more. I need to know more about those 2 points and what are they. Distance, even distance mathematically is a tough thing. Even if I'm given 2 latitude longitudes on a globe, do you want me to give you the simple distance as if I was looking at a map? What projection was that map used? Did it use to create the 2D visualization of the map? You know, if you're calculating the distance on a globe between 2 points, there are many different angles that you could take, and each one of them is going to produce a slightly different distance. So even the word distance needs some clarification there. So sounds very similar, and you might mistakenly think that, yeah, that's not a bad one. I can go into the next room and get started on the problem, but this one really looks like the kind of a problem we need to ask some clarifying questions. So here's another very detailed example. Produce pseudocode to set a variable to 5 and another to 12. Add the variables together, store the result in a third variable, display a message that announces what follows will be the sum of 5 and 12, then display the contents of the variable containing the sum. Extremely detailed, and it's going to be very rare that you ever get a problem in that level of detail. So I would say also another caution is there at the end that when you have experience, like if you're a professional cartographer and you're given the calculate the distance between 2 points, you might be making lots of assumptions from that domain, as opposed to somebody that frequently is asked, hey, you know, I have to go to Cleveland next weekend. How far is it to get from where we are to Cleveland? That sort of general question that we ask sometimes, not being professional cartographers. So careful about that. The more you learn about a particular domain subject area, the more cautious you need to be about whether you're making assumptions. Just becoming more experienced or more knowledgeable about a subject doesn't get rid of this problem. So now I'd like to jump into actually doing an example and give you an example of how to approach one of these problems and complete it and be able to turn it in. So here's the problem statement we're going to work with. Get two numbers from the user, add them together, and print the result. Yeah, I'd say that's a pretty good problem statement. It tells me where the input's coming from, it tells me the processing that I have to do, and it tells me the outputs that I'm expected to produce. And I'm going to expect the pseudocode, the flowchart, and the Python code. And doing the Python code involves testing the software, debugging, iterating on it, and then putting some comments in the code. So let's go ahead and try this. So first of all, what are we going to use to create our solution? I'm going to approach this the way I recommend you doing it, which is to start with your pseudocode. So typically I'm going to say start to denote the start of my program. The solution to this problem, let me make this a little bit larger so you can read it easier on the screen, would be get two numbers from the user. The next step, logically, now I've got my inputs, add the two numbers. And then finally, print the result. So if you were to turn in this file, simple text file, it didn't take me very long to do. I was looking at the problem statement when I did it. I first pulled out the inputs, I pulled out the processing steps, I pulled out the outputs that were expected. I thought about that for a little bit and thought, okay, here's what I need to do. I can't add the two numbers together before I get them from the user, so it sounds like the first thing I need to do is get the two numbers from the user. Next, logically in sequence, is to add them together, and then finally I want to print the result of the screen. That looks great. So if you were to turn this in, you are likely to get full credit. Okay, next, I need a flowchart. Now, in flowcharts, there are a number of different symbols involved. This is simply paint. Now, this is going to look very ugly, and bear with me because I'm doing this way on purpose. When we look at our pseudocode over here, we see the start and the end. So when I do a flowchart, I'm typically going to have an oval for start and an oval for end. And you know, there's my start box. There's my end. You might see these called ovals. You might also see them referred to as lozenges. I don't usually use that terminology, but I've seen people call this shape a lozenge just because it looks like a pill, I guess, that you would take, a capsule. Okay, I've got my start and my end ovals. And then it says get two numbers from the user. So that's going to be an input box, and an input or an output both use this parallelogram shape. You've seen this. It's like a rectangle with angular sides on it. And so going back to the text, get two numbers. Okay, the next thing is going to be add the two numbers together. Any processing steps are going to be inside a rectangle box. So add the two numbers together. And then finally I'm going to display the result. Okay, now I've got a bunch of shapes on here, but I need to connect them together. So I need to draw the arrows, and the arrows need to indicate the direction. So I'm going to put arrows on here, connect up my boxes. Great. So I haven't spent but more than a few minutes, and now I've got my pseudocode and I've got my flowchart. If you turned in for this problem this pseudocode in this fashion, you'd probably be doing okay. Going back to the pseudocode for a moment, let's save this. So I'm going to save this just on my desktop to be easy. And pseudocode.txt is a perfectly good file name. So I save it, and there's my pseudocode file. Then my flowchart here, let me save that. Okay, flowchart and type PNG, that's an image file, that's fine. So I saved my flowchart as a PNG file. Now I need to do the Python code. So let me come over here, and I want to stop and make a point really quick. This is the first time you're seeing this, and the first assignment, I'm basically going to expect you to just follow the leader. Just do what I'm doing, and as you go and as you read the book and as you see more of these examples, it'll become more clear what these things are doing, why they look the way they do, and you'll get it by repetition if nothing else. So listening to me, watching me, and just observing and repeating these steps yourself is part of the learning process. So for a Python program, in Python we have comments which are, look like this. You start out with there's a lot of different names for this. I call it a hashtag, a pound sign, tic-tac-toe box, whatever you want to call it, but it's the hashtag is how you create a comment in Python. Okay, so my add two numbers program. Okay, the first thing is get two numbers from the user. So that's a little general. So my solution is going to evolve. Now we're writing our Python program, and we're at the point to be where we need to be very explicit, and we have to use the actual precise syntax of the Python language. And so again, I don't expect you to know all this. That's what we're here to learn. So I'm telling you how to get two numbers from the user. So the first number, I'm going to imagine in my head a first number, and I'm going to use a variable to store it, and I'm going to call that variable first number. As we've learned in the textbook, a variable is simply a name for a location in memory that holds a value. So I'm going to create an assignment statement where I say my first number equals input. Please enter a number. So that's how I provide a prompt message to the user, and the input statement will deliver that prompt to the screen and stop and wait. And it will wait and wait and wait until the user reads it and types in something and hits the enter key. It'll get what they entered, and it'll return it and send it back to this program, and the program will store that value into first number. So this is what we call an assignment statement. I get something and I assign it to the memory location named first number. Okay, so likewise, second number equals input. Please enter another. Okay, now I have my two numbers. That's the input. I could come up here and put another comment that says inputs. Now the next thing after inputs is processing. So a good variable name for when I add two numbers together is sum. So I'm going to use the word sum for my variable name here, equals, and I'm supposed to add those two numbers together. So like we've been talking about an assignment statement, we have an expression on the right-hand side of the assignment statement. The program will perform the evaluation of this expression. It'll do an arithmetic operation between what's stored in these two variables, and the result will be returned and assigned to the memory location named sum. So that's what we want to read this as, is add first number and second number and store the result in sum. Okay, that's the end of our processing. So outputs, now we're supposed to display the result. So we do that in Python with a print statement. So that is how we would print the sum. Now I made it a little bit more fancy by having that be part of an expression. This expression is going to say, take the character string, the sum is, and you have to make sure you put the spaces in. That's very important for how you want your output to look. But it's going to print the sum is to the screen, followed by the value stored in the memory location named sum. Okay, so in general, that's a pretty good first cut at my Python program. So I want to save that. File, save as, desktop, and I'm going to give it a name, but this time I'm going to call it program.py. I'm not going to use the txt extension because this is a Python program. So I save it, and there's my Python program. Now the next thing is, how do I actually run this? As we discussed with computer languages, there are different kinds. Python happens to be an interpreted sort of language. So we have a Python program that's included with Windows. I don't have to go looking for it. I can just run Python from the command prompt. How did I get my command prompt window? Well, I have a nice shortcut here on my desktop that I can use to launch it. But you can go to the Start menu and just type Command, and there's the shortcut for the command prompt window. So you can just open it. That's what I did to get this window. Once I'm in this window, it starts out in the C:users mark S. That's just my home folder on this computer. So I can hit Python. And that works because the python.exe program is in my path. It knows where to find it. So it tells me what version of Python I'm running here and gives me a little prompt. So I can type Python statements here. So I can say print hello, and it printed hello. It immediately ran that instruction. I didn't have to compile it. I didn't have to save it as a file. You can use Python in this way to do quick and dirty things. Like if I wanted to know, hey, my radius is equal to 12 feet, and I know the area equals pi times the radius times the radius. I have to figure out where the okay, let me show how iterative the development process is. How do I specify? Oh, here it is. It's just all lowercase, math.py. Okay, I was getting there. I was narrowing in on my solution. How about import math? There we go. Okay, sorry about that, but I got there in the end. Now I can say print area, and there's my area. Likewise, if I wanted the circumference, now that I actually know how to get the value for pi, I could say I also have to remember how to spell circumference. I can say circumference equals math.pi what is the formula for circumference again? My brain just went back. Oh, 2 pi r. That's right. Math times 2, math.pi times 2 times radius. And then print circumference. And there's my circumference. So other than all of the little rabbit trails that I had to go to get the code correctly, which you can ignore, all I'm illustrating here is you can run the Python program from your command prompt window without any preamble, without any, it's very easy. It's a very approachable language from that point of view, that all you have to do is open up a command prompt, type Python, and you can start issuing Python statements on the command line. That's my main point. Okay, so, but we have a Python program that we just created that's stored here on our desktop. So the first thing I need to do is I need to find my desktop folder. Where's my desktop folder? Oh, okay. It's on a different drive on this computer. Interesting. But you do have to find where your program is. There we go. There's my files. So my program.python file is stored in this folder on my computer, and in order to run it, I just type python program.py, and it says please enter a number. Let me make this a little bit bigger. Please enter a number. How about 5? Please enter another. How about 12? So then it prints the sum is, and the number 512. Pretty cool. I can run it again to get 2 other numbers. 17, 37. And it adds them together and prints a result. Now, do you notice anything about this? It's not really doing the correct calculation. So this is how we get to a point in our development process where instead of just taking these files, turning them in and saying, okay, I did the assignment, and then getting counted off on them, what we need to do now is to debug our program. Let's look at the first test case. Please enter a number 5, please enter a number 12, and then the answer is 512. Why didn't it say 17? The second one, please enter a number 17, please enter another 37. I got 1,737. Wait a minute. Why didn't I get 54? So it apparently is taking the character 5 and the character 1 and 2 and concatenating them together and printing them side by side instead of numerically, mathematically adding them together. Okay, so what did we do wrong? And it's kind of a trick question. I don't expect you to just know this, but it's a good illustration of how Python works. When I say first number and I get this value on the screen, so when it executed the input statement, said please enter a number, and I typed 17, it assigned that to first number, but it assigned that as a character string, not as a number. So one of the things that you need to do if you want a number from the user is you have to wrap this input statement in an INT. We call that typecasting. It's a fancy term to say you've got one type of data and you're going to cast it as another type of data. And sometimes that's legal. You know, if I take a character string that contains only numerical digits, it's perfectly valid and legal to typecast that as an integer because it contains data that represents an integer. If I entered the word cat and I typecast that as an integer, then Python's going to complain to me and give me an error. Let's see, before I save this program, let's see what happens if I type cat and dog. So the sum is cat dog. So that's a logical error. I didn't get any syntax errors, I got a logical error. But now let me save my program. So I'm going to go ahead and do this for the other instruction too. So now I've converted my inputs into integers, so when the assignment occurs, it's going to put an integer value into those variables instead of a string of characters. Alright, so file, save, come back over here. Now if I do the exact same thing, cat, now I get an error because it says, oh, I'm sorry, I can't take the word cat and cast it as an integer for you as you asked me to do. Okay? So, we can't do that. The Python compiler will keep us from being able to do that operation. It's a legal operation to convert cat to a base 10 integer. Alright, so let's go back to the correct flow. I'm going to enter a number 17. Enter another number 34. Now I get a different error. When I go down to the line, and you know, you can read these errors. They kind of look a little bit like gobbledygook, but if you read them, often it will explain what the problem is. This is complaining about my print statement, where I said the sum is, and I said plus, and the variable sum. So something very different happened when I ran the program this time. Let's follow it through, do a little desk checking in our head here. So I asked for the first number, 17. It got converted to an integer and assigned a first number. I said enter another, 34. That got converted to an integer and put into second number. Okay, now I have first number equals 17, second number equals 34. Perfect. I come down here and it says sum equals. Now, contextually, the Python is going to do something different than it was the first times I was trying to run this program. The first times I tried to run this program, first number and second number contain string character data. The plus operator, this is another one of those differences between programming and math. In math, the plus sign always means a plus sign. In programming, it means whatever it means and whatever it's defined to mean in that context. When you want to add two things that contain character data together, the plus sign says take those two values and concatenate them together and create a new character string. But when now that I've converted those to integers, first number contains an integer, second number contains an integer. When I add them together, instead of concatenating together, it adds the values together numerically and then assigns the result to sum. So 17 and 34 is 51. Now, when this expression is evaluated, it gets the number 51 and assigns a numeric value of 51 to sum. It's not a character string 51, it's a number 51. Then when I come down here to the next statement, the print statement, which is where I got my error, it says print, the sum is sum. So this expression looks very similar to what we were looking at here before. We have a string of characters, and that used to be, sum used to be a character string, when we were adding together concatenating character strings. Now that we're adding together numbers, sum contains an integer. I can't add a character string to an integer. So the solution to this is the reverse of what I did with the inputs. Up here, I had input was returning a character string, and I needed to convert it to an integer in order to get a number in first number. Down here I have a number and I want to get a character string. So I have to do the reverse. Okay, so now I'm taking what is stored in sum, converting it to a character string, and then I'm adding or concatenating that together with this character string to get the answer. Okay, let's file, save that. And I'm going to come back over here and run my program again. Please enter a number, 17. Please enter another number, 34. Enter. And now I correctly, finally, at long last, get the number 51. Okay, next step would be to take these three files and upload those to Canvas as my submission for the solution to this problem. All three files you would want to upload. Okay, we want to take a deep breath here and review what we just did. We analyzed the initial problem statement from the PowerPoint slide that said get two numbers from the user, add them together, and print the result. We created our pseudocode. We created our flowchart. We wrote the Python code, and then we tested the Python code. We ran into errors. First of all, it didn't look like there were any errors, but when we looked at it carefully, we realized we were getting the incorrect result. So we analyzed the result, looked at our algorithm, and realized that we had an error. We debugged our program, correcting the error and trying again. We realized that we had another problem. We corrected that error, tried again. We realized that we had a third problem. We corrected that error, tried again, and then finally we got the correct result. And that is a very typical homework life cycle that you're going to repeat over and over and over again in this class and any other programming class that you take as follows. Okay? So I would expect that you could take a problem statement from me now and watch this video again and again and again, repeat the exact same steps that I did, and get a similar result, and hopefully get something close to full credit as a result. End of statement. Okay, where I want to go from here is I want to clean this process up a little. The pseudocode was okay. The flowchart, we can do a lot better than this. We can use the Flowgorithm tool. We can use Raptor, Lucidchart, Visio, any number of diagramming tools to get a better flowchart here. And I want to walk through a demonstration of that, how we can get something better than this flowchart as a result to be able to turn in. So let me run Flowgorithm. So that's what it looks like when I launch it. But first I want to make sure that you understand how to where's my browser window? There it is. Okay, so when you go into your browser, you can go to flowgorithm.org and click on the downloads link. On this download tab, there's a Windows installer. That's where you download, well, assuming that you're on a modern Windows computer, a PC, you would download Flowgorithm and then run that installer and install Flowgorithm on your computer. Similarly, if you go away, add. Okay, raptor.martincarlisle.com is the correct URL for that. You know, you can Google for Raptor flowcharting tool, and you can get to the same place, but it's www.raptor.martincarlisle.com. And this one will work if you're on a PC or on a Mac. You might have to scroll down here and find where the file is that you want to download. Like I said, this is an older program. The website's not that great. It's not very clear. The install instructions aren't great. But they do have a Mac version of the tool that you can try to install and get running. I'll let you know a disclaimer right up front. I'm not a Mac person. As an FSW student, I believe if you have a Mac, you can take your Mac into the IT department and they will help you get tools installed. So you could probably take that over to the IT building and ask them to install Raptor with you and get it up and running if you can't figure out how to do it yourself. There's also a tool called PyCharm. So when we talk about what to use to create your Python programming, your program, I just use Notepad, as you saw here. It's just a simple text file with a .py extension that I was able to run from the command line. That's all I needed. So I don't want anybody saying, hey, I'm blocked because I can't get PyCharm to work, or I'm blocked because I can't download Thonny and get Thonny to work. I'll go ahead and show you that also. So here's where you go to get Thonny, the tool that we use in the classrooms. It's installed on the lab computers. So you would click the Windows download or the Mac download for Thonny and install that on your PC or your Mac. So I don't remember what these URLs are off the top of my head. I typically just go search for it and download it and install it on my computer to get going. But we'll be using Thonny quite a bit for examples in class on how to do this. I may show you from time to time how to use PyCharm. This is more of a professional development tool. If you're using Python in the workplace, you might have a license to use PyCharm. So keep that in mind, that is an option that's available. As a student, you're allowed to go to JetBrains and create an account and get an educational license to use PyCharm, and it's a really nice tool. Like I said, in the future I may do a demo on PyCharm and go through some of its features, but for now we're going to focus on Flowgorithm for the flowcharts and Thonny for the Python programs. Okay, so I've got my flowchart here. Once you've got Flowgorithm installed, you'll run it, and it comes up with a blank template for a flowchart that looks something like this. Let me zoom in a little bit. It starts out very similar to the way I did when I was in Paint, with a start and an end. Now, whether you say main and end, or start and end, or begin and end, begin and stop, the particular words that you use, I'm not so concerned about, because again, we're communicating with humans here. I use start and end. Flowgorithm uses main and end. Other programs may use other conventions. That's all perfectly fine. You don't have to be concerned that that's going to be misconstrued. But you can tell it's got the right kind of shape, the lozenge shape, and they use that shape for the begin and the end box in our flowchart. Okay, so I want to replicate something similar to my manually created flowchart over here. So the next thing I need to do is add boxes in between here. The way you do that in Flowgorithm is you come to this arrow, and notice it changes colors when I move my mouse over it. So I want to click somewhere on that arrow, and this little box comes up. It says, okay, what do you want to add? Oh, look at that. It even tells me. So in Flowgorithm, the blue input box, or blue rectangle, or parallelogram, is for input, and the green parallelogram is for output. For me, color doesn't matter. It's the shape that is important. So I'm going to click the input box, and it adds an input box. I can go right below the input, and I can click it again, and it says assign. Oh, there's an assignment. I need to put an assignment statement in my program, so I'll click the assign box. Click it again, and I get my output. Now, one of the things that's important, we talked about this in chapter 1, is declaring variables. Python is a programming environment where I've got several variables that I'm using here in my Python program, but I did not have to declare them. It's perfectly okay. Some people, I'll see them come up at the top and they'll make a comment that says that, hey, by the way, I'm using these variables. Okay, that's just kind of self-documenting. That's fine. I have no problem with that at all. In fact, I'm not going to require it, but it's definitely encouraged if you feel inclined to put a comment like that there at the top. That's fine. But in Flowcharts, much like programs like C#, C++, other programming language, Flowcharts in particular requires you to declare your variables before you use them. So if I come up here at the beginning of my flowchart after main and I click on this arrow, you'll notice that there's a box explicitly for declare. So I'm going to click on that. Okay. Now I need to start. I've got the general shape and flow of my flowchart. I'm going to double click on this declare box, and it says a declare statement is used to create variables and arrays. These are used to store data while the program runs. That's exactly what we know a variable is. Okay, so what variable names are we going to use? First number, comma, second number, comma, and sum. Those are the three variables that I intend to use. And yes, they're all three integers. If I was going to create some integers, some floats, some strings, I'd have a different declaration box for each type of variable. But for here, all of my variables are integers, so I just list them all here separated by commas, and I'm good. Next, my input statement. So what variable do I want to put this in? This is my first number, and click OK, and it says input first number. Now where's my prompt message? I didn't get a chance to say please enter a number. Well, remember this is just a flowchart, so I don't need to be that detailed or that explicit. But if you wanted to, you could put a prompt message here and say please enter a number. But the Flowcharts tool does not give you a chance to enter your prompt. It just says give me the name of the variable that you want to stick the value in. Okay. I need another input statement for my second one. So I'll add another input. Double click on it. The second variable is second number. Okay, input first number, input second number. So I've got all my inputs. The next thing is my assignment statement. Let's see, my sum on the left side of the assignment statement is the output of the result, and the expression that I want to evaluate is first number plus second number. So now it looks very similar to the assignment statement that I wrote in my Python, sum equals first number plus second number. So I think we're good here. And then output. So what do we want to output? Enter an expression below. Now here it's an expression, it's not just a variable name. So now they let me put a prompt message in. The sum is, and my variable sum. Similar to what my print statement looks like. This is what I'm going to print. Okay. So there's my flowchart. So if I save this and turned in, this is going to save as an FPRG program. You can see that down here in the save as type box. So I'm just going to call this flowchart. I'm going to put it on my desktop with the other files. There we go. Now, the great thing about Flowgorithm is this feature right here, the little green triangle at the top. So once I've created my flowchart, I can actually run, I can execute my flowchart. So let's look at what that does. So I click the play button, and I get this window that shows up, and down here in the little bitty tiny print at the bottom it says, please enter a value of type integer for first number. This is a little different than Python. It is declaring these variables, and we told it what type to make it, and that's the reason why in the flowchart here we didn't have to do all this typecasting to an integer and then back to a string. It's just Flowgorithm works a little bit differently than Python. Again, our intent is not to write the program in Flowgorithm. We're just creating our flowchart. We already did that. So I'm just telling you a little bit of extra benefit that you can get from doing your flowchart in Flowgorithm, which is I can execute my flowchart before I go to convert it to Python and get it to run over there. Okay, so I'm going to enter my first number, 38, enter, and it just repeats. Okay, here's what you said. It's kind of like a chat dialogue back and forth. The inputs are over on the right as chat messages that I send to the program, and as you'll see, the outputs come back as chat messages that it's chatting back to me. So now down here at the bottom it says, please enter a value of type integer for second number. Okay, 18. Enter. Now I get an error. This is very similar to what we went through with the Python program. I didn't do something right. Okay, so it says the add operator requires two numbers. The specified values cannot be converted automatically. The following were specified: string and integer. Okay, so what did we do wrong? Let's see. Okay, it turned my output box red, so it indicates that that's where the error is. So apparently my program ran correctly all the way down to where that red box is, and I'm guessing that I have the same problem that I had when I was doing the Python, where I've got the add operation, but I've got a character string and an integer. So let me double click on that box again and look at this. Okay, the sum is plus sum. How about if I just put a comma? I'm experimenting here. Nope, it doesn't want that in the expression. So I'm just going to back off and I'm just going to say sum. I'm just going to list the variable name. Okay, now let me run it again. Enter the first number, 25, enter. Second number, 14, enter. And I didn't get any errors this time. And 39. Is 39, let's see, 25 plus 14 is 39. Yeah, that's the correct answer. Okay, so that worked. So I was able to successfully run my flowchart and verify that my logic was correct. Now, we don't have any what I would call logic going on in these simple programs at this point. We'll get to that very soon in the semester, where we've got logic that we're evaluating, and you'll get different results or follow different paths through your program depending on what the logic is that you code in your Python program. But for now, it's just going top to bottom, and so it's not as useful to use Flowgorithm to evaluate your logic's correctness or not, but the value of that will be evident, like I said, very soon. But one of the interesting things about this is, now that we've got this flowchart working in Flowgorithm, is if I come up here to the menu and let me look around, tools, file, edit, appearance, program, there's a menu item here that says source code viewer. So if I click on this, it brings up this window, And the main thing I wanted to point out about this window is if you're questioning whether your pseudocode was correct or not, let's go back to our pseudocode. So here's the pseudocode. So as we discussed earlier, the flowchart and the pseudocode are serving the same purpose of just describing what our approach to the solution is. The flowchart's a graphical representation, the pseudocode is a textual representation. But just as a double check, we can look at the source code viewer in Flowgorithm and look and see what it says and compare it to our pseudocode, and they look very similar. So if you're having trouble with your pseudocode and you want to know if you got it correct and you got your flowchart to work in Flowgorithm, use this source code viewer and just double check and compare the similarity of it, and yeah, that looks pretty close. It looks like they're both correct. Like I said, it's hard to get the value of this now because the program is so, the problem was so simple. Add two numbers together and print the result. But as we get later into the class and we get more complicated programs, remember this because it has some value to it. Okay, so using Flowgorithm, I would, instead of using this this PNG file that I created in Paint, now I would turn in the Flowgorithm flowchart, the Python program, and the pseudocode. Those three files is what I would turn in for this assignment. And like I said, feel free to watch this as many times as you want to. Repeat it on your own. And oh, the last thing I wanted to do is I wanted to run Thonny and do the same problem, but inside the Thonny editor, so that you can get an example of that. Again, I've already installed this on my computer, so you'll go to the web page, search for Thonny, and download it and install it on your computer, and you'll get a, when you run it, you'll get a window that looks sort of like this. So again, I went to the Start menu, I typed in Thonny, it'll look like this, and I clicked Open. Okay, so in Thonny, I'm going to do the exact same thing I did earlier, create my program. I'll put a comment in. Actually, I can just copy and paste to save some time. Here's the program that I already created. I'm just going to copy and paste it in here. Now, another nice benefit of using Thonny or an editor like this, PyCharm or other, Visual Studio Code, other editors have this value also. But notice how it made my comments gray, and it kind of syntax colored the parts of my instructions here. When you're trying to read lots and lots of source code, this is very helpful. It just kind of plugs in with your brain and makes your code so much more readable. It's a very nice feature. Notepad doesn't have that feature, but these other IDEs, these editor development environments, they have that feature, and it's very nice. Okay, so here's my code again. In order to run it, I just come up to the little green triangle at the top. I play it. Now down here in the shell window, it says please enter a number. Once again, I'll pick a number, enter another number, 72. I'll hit enter, and it prints the sum as 115. So, we've already debugged this code, and we already knew that it was working correctly, but I wanted to show you doing the same thing in Thonny and how it worked. Before we leave Thonny, I want to show you another really cool feature of Thonny is this debug button, the little picture of the beetle up here in the toolbar. So if I click on that, what happens? Oh, I have to save it. Yeah. So let me go to my desktop. I'm going to pick program.py again. Yes. Okay, now it's saved. And let me click the beetle again. What happens? Okay, it highlighted the first line. So the way this works is this is a debugger, Thani is acting as a debugger right now, and it's going to step through each line of my program one at a time and execute it interactively. So it's stopped on the first line of code. It has not executed it yet. So there's really nothing to look at. I've got these 3 buttons here at the top. Step over, step into, and step out. First of all, or at this point, we really only need to worry about the step over, or I can use the F6 key. So if I click the step over button, it says, please enter a number. It has now executed that first line of code. It paused on the input statement, please enter a number, so I'm going to enter a number and hit enter. Okay, it goes back into the control of the debugger, moves to the next statement. It's completed the first statement, it goes to the next statement. But while I'm sitting here, first number, I can look at that and see what it has in it. View variables. So this window pops up over here, and look, I can see that first number has a value of 54 in it right now. That's extremely useful when you're debugging and trying to figure out what's going on with your program. I can resize these windows a little bit to make it a little bit more pleasing. Again, my debugger is stopped on the second instruction, so I'm going to say step over. It says please enter another number, 32, hit enter, and now I see second number over here has 32 in it. So this is like a running tally of all of my variables and what value they contain currently. It moved on to the next one. It hasn't executed it yet, so I'm going to hit step over. It stepped over it, and now I have the sum variable with the value stored in it. It's sitting on the print statement, and I can execute that. Step over. It executed that statement, said the sum is 86, and then the program exited because it didn't have any more instructions at the end. This is really, really cool. When you have a complicated program, the ability to step through it, similar to the way we did our Flowcharts when I ran through it and saw it working. You know, this is really valuable in Flowcharts to be able to do that, and it's really valuable in Thani to be able to debug my Python program. So I think that's about everything that I wanted to cover, and I hope that was valuable to you, and feel free, like I said, to go through this video as many times as you need to, and just the first assignment or two you're just going to be following the leader, and that's perfectly fine. So with that, I will end this, and we will see you next time. Thanks for your attention.